Hey guys, welcome back to another video. Today we're gonna be talking about breadboard. Very simple. I've been playing around with this breadboard for about a week now, and I want to show you guys some of the cool stuff I've learned. So the goal for this channel is to somehow get to the end where we get to build a drone with everything we have learned so far. So this is just the beginning. So I've been playing around with this breadboard for a week, and I want to teach you guys what I have learned while I've been doing this. So that way, if anybody else wants to get into some tinkering, this is the perfect channel to do so, because I don't know nothing about circuits. I don't know nothing about resistors. I don't know nothing about circuits and none of that stuff. So I just woke up one day and I was like, I want to build a drone. How do I do it? And I went on the internet and I started Googling stuff. So this is what this channel is going to be about. We're going to learn together, and let's see at the end we can get to our main goal of building the drone and having it functional with 3D printer part. So today we're talking about breadboard. I've been playing around with this for like about a week now, like I said, and I think they're very cool. So some of the basic components of a breadboard. So a breadboard is pretty much used to design circuits without soldering. That's the basic definition of what a breadboard is. It's pretty much used to design circuit boards without having to solder. So that's one of the cool things about it that I've been playing around with. Most of the projects I've been doing is mostly learning how to code the Arduino, because that is a big component of this project. Another thing is just learning how voltage works. That's one of the big things also I'm trying to dive into, is learning about 5 volt, 24 volt, 12 volt. I don't know how many voltage. Like I said, we're new to this stuff, so I've just been learning about voltage and trying to understand it, playing around with my multimeter. But in this video, I'm gonna dive into some of the breadboard features. So to start off with, a breadboard is just a plastic piece with a few colors and a lot of holes. I mean, it sounds simple, but it's actually a lot more complicated than it looks. So as you can see here, this is the breadboard right here. So on the both ends of it, you have your red line, your blue line. Those are your power rail. So this is where you will route your power through if you want to power the projects on the board. You have your positive and your negative. I'm going to demonstrate that in the simulation very soon, so no worries. But besides that, it's very basic. And in the middle is where you connect all your pins and all your circuits and stuff. So it's a very cool piece of tech that exists. And with this thing, you can pretty much tinker to your heart content, as there's no limit to what you can do with this. I mean, if you check out some of the other YouTube channels, a lot of people have built like full-on processors, video cards with this thing. So it's definitely a cool piece of tech. And hopefully in this video, I'm able to master it and we can build out a nice drone that can just fly around, and let's see what kind of features we can throw on there. So let's go ahead and dive into the simulation so I can show you guys what I've learned and some of the cool things about the breadboard. So let's go ahead. All right, here we are in the simulation. So as you can see here, we have a virtual breadboard, and this is a better visual representation of what I showed you guys earlier physically. But here we can play around with a bunch of other tools that we have at our disposal. So let's go ahead and dive into it. I'm excited. So here we have a basic breadboard. So first is very important to understand the connections on the breadboard. So the first thing I want to show you guys is this software makes it easy for you to visualize the connection. And so as you can see here, the negative power rail is connected horizontally across the board, while the pins are connected vertically. So when you're using the breadboard and you want to power, just remember when you apply power to one pin here, once you apply power to the power rail, all the pins are now powered. So let's go ahead and demonstrate that right now. So I'm going to grab me a 9-volt battery right here. Let's go ahead and zoom out a little bit. And then we're just going to apply the negative to negative and positive to positive. So now let me go ahead and grab a multimeter, as this software also does give you a multimeter. This is why I love this software. I'm going to put the link in the description for anybody who want to check it out. It is free to use. You just have to create an account, just letting you guys know. But let's go ahead and grab a multimeter and then test out the voltage here. So I have me a multimeter here that sets a voltage. So let's go ahead and connect the negative to negative and positive to positive. And then let's go ahead and run the simulation. So at the top, you have to run the simulation in order to mimic the real world, what would happen. So in this case, let's go ahead and run the simulation and let's see what happened. There you go. So now we have a 9-volt power going through the first power rail. But what if I also want to power this one with 9 volt? How do I do that? So I only have one cable here. Well, technically I could I can split it. The software let me split it, but generally in real life, you're not going to be able to do this. But let's just go ahead and demonstrate how we would normally do it in real life if we were using an actual breadboard. So let's go ahead and remove these two prongs. So we know that this rail is power. That's not a question. So we know that we're getting 9 volt between on this power rail, but this power rail right here. So if I test this one, so we go to negative to negative, positive to positive. If I run it, we have no voltage here, which makes sense because we don't have any power going through here. So let's go ahead and fix that. So here we go. Let's go ahead and remove these wires. So now, since this rail is already power, all I have to do is just take the power from the first rail and put it in the second rail, which as easy as it sounds. So let's go ahead and take the positive, give it to positive, negative, give it to negative. I think we should be good. Oh, no, not yet. Okay, so now we have positive to positive, negative to negative. Now let's see if we have a 9 volt running through the second power rail on this on this breadboard. So let's go ahead and connect the negative, positive. Now if I run the simulation, bam, now I'm getting 9 volt between both power rail, and all we did was we just connected the negative to the negative and the positive to the positive to the second power rail. So now both rails are now powering through 9 volt, which is awesome. So let's go ahead and dive into the next project. Okay, let's go ahead and grab an LED light and see if we can get that to power on. So let's go ahead and grab one. All right, so I have a red LED light here. I'm gonna change it to yellow because yellow is my favorite color. And let's go ahead and add it to pin 8 and 9. Before we even do that, I want to talk about one thing about electronics. So something like an LED light, one thing to remember is a lot of things have polarity. Something I just learned. So there you go. So you have to understand that some things like LED lights, they have a positive and a negative connection. And it's good to know which one is a positive, which one is a negative, as you don't want to destroy some of your components. As we get into more of the drone building part, that's going to come in handy to understand, as understanding the polarity of electronic components will help you save some of them and help you save a lot of money and a lot of destruction. And this is why this software is very good, because you can't break anything physical here. All this is just virtual. So it's fun to break stuff in here because I don't know, I don't feel like rebuying everything every time I make a mistake. So let's go ahead and dive right into it. So here you can see we have we have 2 connections on the LED light, and one of them seems to have like a slight bend on the leg. So that's basically telling you this is your positive connection and this is your negative connection. So generally in real life, the longest pin on the LED light is your positive connection and the shortest pin is your negative connection. Just keep that in mind whenever you're powering LED lights. There's more stuff with polarities, but just understand that. So go ahead, how will we power this, right? So let's see. So let's put this in 7 and 8. So we know this is our positive and this is our negative. So basically, can we just connect, actually, yeah, we can just do this. So can we just connect positive to positive and then negative to negative? We can do that, but I know what's gonna happen when we press that simulation button. So let's go ahead and do it since there's no consequences inside the simulation. So let's go ahead and run it. Oh, okay. So as you can see, our LED light just blew up. So why did that happen? Of course, I'm gonna dive into that. So you can power things directly, but the problem is everything has a maximum amperage that they're able to push. So for example, this LED light is able to support a maximum of 20 milliamp, and I'm pushing 900 milliamp right now into the LED light. So of course it's gonna pop. But how do we fix this? So let's go back. So we know we're powering everything with 9 volt, right? So this is where the resistor comes in. You know, very, very scary name, but the resistor is a very helpful thing that's going to help save you a lot of your electronic. So let's go ahead and grab a resistor. So we have one resistor here. So how do we put this resistor into the mix? So we just know that a resistor pretty much resists electricity. So as the name sounds, it restricts electricity. So imagine a hose that's open, but then you apply a little squeeze to it to sort of let the water trickle. That's what a resistor is. So when I plug those two negative, when I plug the positive and the negative to the wire, there was no limit on how much power can push through. That's why the LED light blew up. By adding the resistor, this will limit the electricity from going through, and save our electronics from blowing up. So let's go ahead and add it. So let's go back to it. So we're gonna add the positive to positive, and instead of putting negative to negative, we're gonna throw a resistor in between them. So now the resistor is now connected to the negative pin, and we're gonna connect the negative to the resistor. So now my resistor is only set to, I believe that's one. I have to learn how to read my resistors, but that's another video I'm gonna do soon because I am studying resistors right now. They're very fascinating equipment, but the colors on the resistors are meaningful. So that's gonna be another video for another time. But right now we're just gonna leave it as basic as it is gonna save the electronic regardless. But let's go ahead and power it. Let's go ahead and run the simulation and see what happens. Okay, now we didn't blow up. The LED light did not blow up, which makes sense because the resistor is now limiting the current. So instead of the LED light getting the full 900 milliamp, we are now getting a probably tame 100 milliamp to the LED light, which is still overvolting it, but because I did not adjust the resistor here, but so far we did save the electronics. So this just shows you that a lot of time when you're playing around with electronics, just make sure that you understand how electricity flow, and this is a big important thing. You can break a lot of stuff if you miswire something. That's what I'm learning, and that's why it's very important. But that's all I have for this video. Thank you guys for watching. If you guys have any questions, definitely put in the description. If you guys have any corrections, because I know I made a few mistakes in this video, please let me know in the description. Is anything I missed or something I should know? Please let me know in the comment too, because I do read those comments. So I do appreciate you guys for watching. Thank you guys for watching. Peace.